at this channel here. This guy's building a nice roof deck made of concrete. Let's call it a roof deck. The deck part holds the car, the automobile. And let's refresh the page. And
welcome back to.
Let's fast forward a little bit. Let's fast forward. There's his, these are his temporary supports or permanent too, I believe. He's going to keep them in place for.
A metal C channel that's embedded in this, and that one there, and that's gives it the rigidity to hold flat while you're stacking them out there. It's not enough to hold the concrete. That is why we'll have the jack stand.
All right, not enough to hold the concrete. He understands that. Now, they're going to bend these bars over into the top of the form, the deck. Let's get to that. Let's jump to that. And then with that, therein lies the devil in the details.
Now, I'm going to climb down here close to the edge.
So here's their formwork, and the reinforcement is laid with chairs on the bottom of the formwork. That's very critical there. It's laid on the bottom of the formwork. Let's back up a little bit. The bars that are bent over, the concrete will receive another 4 inches of concrete above here. They're bent over with this human just bending over with this heel of his shoe. And look what's happening. It's coming in contact with this formwork. The formwork will get concrete on top of it, including down in these pockets, which will form a beam, if you will. But as you can see, that once the ceiling is removed, if the ceiling was ever removed, which I don't think it will be, the concrete, the reinforcement is not embedded. It's at the bottom of the reinforcement. Here it is. Here's got two pieces of rebar just twisted together also. Two there and two here. It's not embedded, and it's exposed concrete just laying on the foam there. So this detail, he said the engineer specified bending over the rebar into the concrete. Well, that's not into the concrete, that's into the foam. And now here we have the rebar again in the bottom of the beam, approximately these chairs are, I don't know, 1.5 inch chairs. I mean, from the base to the underside of the rebar, and then these are 7/8 rebar. So center line's about 2 inches approximately. He stated that you can just add more of these just to make a greater span. Let's see.
Even more longer span or more weight, you just actually stack another one of these on here, which makes your leg even deeper. Then we're going to have the 1/2 inch and a 2x2 mesh that goes on top of this. So let me climb back up so you guys can get a better view of it. And then you have this second piece that goes on. And so what it makes is our channel nice and deep. And then we're going to have another 4 inches of concrete that goes on top of that. So we're going to have a nice deep channels. This is 3/4 inch rebar that goes here. And then we're going to have the 1/2 inch and a 2x2 mesh that goes on top of this.
Okay. This is the 1/2 inch reinforcement. And then a 2x2 mesh that goes on top. Let's 1/2 inch and a 2x2 mesh goes on top. Remember, you said they stated that. The rebar is just bent, laying at multiple directions on angles. Here's his propping. Listen what he states.
We'll have a 2x6 is the horizontal across the top, and then we have a 2x4 that is set on a T. So you have makes a T, makes this thing super rigid. So after all this is poured and we wait, let it cure out, it'll probably be somewhere around 30 to 40 days to make sure that the cure is out. Then they'll come through, we'll take all of this out, and it's one span. And what's neat is they build in just a little bit of crown. You notice, I don't know if you can see it on the video, there's a little bit of crown right here in the middle of the garage. So when everything sets up and we pull the jacks, and then the full weight of the concrete is realized, it'll have just a little bit of settling, maybe about that much.
So he said maybe about that much, looks like over an inch. Well, that inch has to display somewhere. Where's the inch of crown displaced? Well, it pushes on the outside wall, more so at the top of the wall, creating probably a reaction somewhere about here in this wall. I would just guesstimate compression on the backside of the wall and tension on here on this face of it. So it changes it from a fully compression type wall to now a wall that's got a moment in it somewhere about wherever this huge um, this huge gap that he describes will be closed.
And we pull the jacks, and then the full weight of the concrete is realized. It'll have just a little bit of settling, maybe about.
Let's call that about a good inch. Well, that inch of settlement again has a moment that's going to have to push. That's going to have to resolve being pushed on the wall. He says the engineers designed that.
Not that much, but maybe it might not be. We put in 3/4 of 1 inch, and so if it drops at half, I still have just a slight crown. So when we're
they said he's put in 3/4 to 1 inch.
Parking the cars, big cars, even if it has any deflection, it'll still be nice and flat. But that's all built in. That was from the engineers to add just a little bit here on the front end, so that if it's perfectly flat and you pull this off and it settles, it might have a little bit of a dip to it. So we didn't want that.
All right. So imagine this piece of rebar flat here is this line right here. Let's use this red line as a reinforcement. He just crowned it. He just pushed it up in there about 3/4 of an inch. Well, if it drops down, it's going to now flatten out, as he just stated. Now, it's bent up right now in the up position, so this dot is no longer there. It's here, let's say. And when you have that crown in it and it goes back out, that dot is no longer where my little pointer finger is. It now goes back to here. That puts that rebar acting more in compression now. It's pushing down, the floor levels out and starts pushing the wall out because it's at the bottom of the form. It's not pre-shaped in the middle with the pre-shaped. It's following the bottom of the formwork. So it's 2 inches off the bottom no matter what. And then when you sag the floor, when the sagging takes place as he describes, the rebar is not going to really be acting in tension. It's going to be acting more in compression, trying to resist the compressive forces that want to push it back out. Not the tensile, not in tension, because it's embedded in the concrete at that point. It's one with the concrete, but the concrete is also made the rebar pre-bent in a crown capacity. So normally it would be in tension if you had it just at the bottom and then you dropped it 2 inches. That rebar would be, if it was flat and at the bottom, flat and at the bottom, the rebar, and then you try to put a 2 inch reaction on it going down, that rebar would be in tension at that point. But your rebar is also crowned. And so therein lies the devil in the details. Since it's now crowned, but just exaggerated. It's pushed up this way like a pyramid, and pyramid this way, exaggerating the crown from here to here and from here to here. Now push down 2 inches. You see now the rebar is in compression. It's not in tension. So yes, it's a small bit, but the rebar is not. It's going to have two reactions. It's working 2 ways now. It's got that compressive moment going on if it flattens out. Interesting though, I visualized that if it could actually dip below there and create a sagging effect of dip below the same amount that it sagged up, that it was bowed up, then it would be back status quo, except for you just had a moment inside the concrete where the rebar was forced in compression and then pulled back in tension as it goes from bowing to sagging. So that's not for free. You created some surface tension against the rebar and the interaction of the integral interaction with the concrete. I had a nice sample to show you guys on that, the rebar and breakaway with the concrete. I don't have it with me right now to do that. Let's fast forward to his formwork and him setting up. So there are the chairs. The reinforcement is just not lined up yet. There's it touching again. Here's it touching the formwork. So the concrete rolls over into here, as he says, all the way up to here. And yet the interaction is such that if you were to remove this formwork, you would see exposed rebar because the bends are, I don't believe what the engineer intended. I think he wanted them up here at the 2-inch mark, so the bend would come here, rotate, and turn here. And that would require a tool, not a foot, to do this.
And drop down into it. This here,
one after another,
is so when the concrete comes up, it looks like it'll probably be somewhere around
fit and finish. This is how hard would it have been to get the proper board to make this the correct height. He says this is the elevation height. He also points over here equal with the floor height. He says once they finish the floor, so the floor is going to have a extended height. So appears he's got a block layer laying ledgers and formwork that's going to be a little bit of require some more shimming.
On this level right here, that matches up with if you're going to put the subfloor on, so that when you walk across, it's a straight entry all the way.
That'd be one level of subfloor and straight entry stated. If the door is way back here and there's no water, the water can get back there. Then it's probably legit. But most codes don't allow you to walk from your concrete right into your hard. You have to step up of some type because of a lip. Step up because of the. I'll say step up. It's some lip to keep the oil and water out of your house.
And it only really matters at the door opening there, but we want to make sure it's as close as possible.
All right.
And then we have some extra sleeves, and I talked about the ERV, which is the Energy Recovery Ventilation, and that brings out as a return. Before our concrete truck arrives, I thought it's nice and quiet here now, so I'm going to turn around so you guys can see what the floor is going to look like now that we have everything braced and ready to go.
Braced and ready to go. All right, he said 2x2s and mesh. Mesh rather, wire. Do you see the mesh? I don't either. So apparently this contractor decides you don't get the mesh. But wait till he gets over here for that detail we talked about. He's going to climb in.
Out for you. So for the opening of the garage, that'll be the top of that 2x12. This will be braced back into the earth just in this area so that it doesn't want to lean out with any of the pressure of the concrete. And then
So now here we have that detail we talked about. There's this reinforcement. It comes up short. It doesn't make itself into development. It doesn't make itself back into the wall there and back over, tying together. So we've got spacing of I think these two come up. This one comes up, and this one I don't know where it's going, but this one comes up short. This one comes up short. Which comes up short. These are all just exposed on the ceiling if you remove the foam there.
Go up down here.
It's right here, and then this is no longer where the engineer didn't design it. I'm sure the engineer didn't say have one section of the rebar bend out. It's just, I guess this, I don't know what municipality this is, but it's quality control
and you
now.
Can see where
now concrete's supposed to go through this wall here, and your embedment again is just touching off of this, on this foam. So there's no embedment of this. This is at the bottom of the concrete at that point. So that's very critical, and it's not done.
Will continue on up right there, but they've cut the bottom part out of it.
So imagine that deflection part he talks about going back down. This is going to just buckle what? It's going to move out and it's going to start buckling this rebar or putting a force on it. This is because it's exposed. Remember, the rebar is exposed, so it's not embedded in concrete. It won't have its design intent to be wrapped in concrete, not acting like some dowel, exposed dowel.
So that the slab, when we pour it, will go under that and then down into it. And I'll walk.
And he said 4 inches of concrete. That's clearly very, very small.
I'll walk over there so that you guys can see.
Let's look at this.
Just a second.
Let's let him cross over as you stated.
Okay, so let's go over here to look at one. So when we pour the concrete here,
and as you can see here, the concrete will be.
It's going to go here. It'll hit somewhere about right in here, right? Because we're 4 inches.
4 inches off the foam. So the cover of this concrete now puts the reinforcement at the top of the concrete, not at the bottom of it. The top of the concrete, not at the bottom, which is not where this reaction is going to be taking place. It's taking more so at the bottom of the concrete is where you would have this reinforcement. He's got it up at the top. So, and it's only got about, from his finger, 1.5 inches of cover. I hope his vehicles he puts on this thing are pretty light. I hope they're pretty light. Now, connecting those beams to this are the cross steels. The main beams would be, the main bar would then be, well, a couple of main bars at this point. You know, the beam structure, and then the ones connect from one to the other to transfer the load would be main beam also. I'd like to think of it as that.
Right here, but
main steel. I'm sorry. The main bars.
So when we pour it, we'll start to go under that.
So it goes under that. It touches here, as we can see. So it's exposed. He only puts the concrete right about here, which puts the reinforcement at the top. And it just seems like they should allow the engineer to come out and do the inspection.
It'll go down here and then turn, and that's where we get the lock-in from the wall to the roof of this. And so that's what makes the monolithic pour, so that and then this whole structure hooks together.
So he has that little gap hooking the entire structure together. This gap is
then turn, and that's where we get. It'll start to go under that.
His gap is here, connecting there. That's a wall that goes up more for him on top here. So ignoring that, this floor pad is connected with however the beam is overhanging into this area here, those beam pockets, and then these bent reinforcement that's at the bottom here for sure, and then it turns, and here's a 4-inch mark. So if that's 4 inch, if that's the 4-inch mark that he pointed at with his finger, then we've got the reinforcement up here at the top 1/3 of the reinforcement with not much cover. So I can imagine that this flexing he's talking about that's going to take place could have some blowouts of concrete.
And then it'll go down. It'll go down here and then turn, and that will show you guys.
So here's his reinforcement again. This is there's that beam here, and to tie the beam together to the rest of the pad above, you only have these cross members spaced. I don't know how far they're spaced apart. It looks like they got some greater than 12 inches. I don't see the mesh that he detailed, that he spoke of. And this is just on its own out here, not tied in. And this is on its own. Oh no, it's not quite tied in, but there it is around the chair. So this one's in the bottom third, if you will, of the concrete. This one's in the top third, but only out to there. And this one's just, you know, it's not. This is where they put their foot on it. So it's just bent over like that. Yeah, this is the craftsmanship for you. Let's fast forward. There's those beams. Again, these are set flat on chairs. So when they crown it, it's going to have an issue. Take note of this chair. This chair is touching down here, but not over here. So the bars are not consistent with their placement. See the bar, see the gap there? So it's high on this side and touching down on that side. So this rebar already has something going on with it. This reinforcement. The profile is not consistent. And then he crowned it. I don't know which way he crowned it. Was it this way, or was it this way? You know, his beams are going this way, so I would hope he crowned it. If you're going to do something like that, crowned it this way, because that's where the beams would deflect, and the beams would be deflected. If you did it here, you did nothing. You basically crown between two beams, and you're going to create a nice little break point. And I think that is the way he might have crowned it. Let's go back and see if he crowned it. So which doorways to go through? This one? And he might have crowned it this way. I don't know, but it doesn't matter because the reinforcement appears to be all in the wrong location, unless somehow his engineer says, "Oh, that's great. I like the way you did that." So paste is falling through. So there's plenty of gaps up there that he didn't reinforce with foam, and that weakens your concrete also. The paste is falling through, not the rocks.
All right, so this is one of the finishes.
You can hear it. Oh.
Man, that's amazing. All right, so this is one of the finishers.
So here's the finishers with the vibrator. Is vibrating a surface. It appears that no one really cares about making sure that reinforcement gets concrete around it, because they're just all standing out here already and the concrete's already rolling back. I don't know what slump this is, but here we go.
His name is Alex. This guy is a master at his... Oh, no! We give him a hard time for keeping his equipment so clean, but overall, they love it. Nice and deep, and then we're going to have another 4 inches of concrete that goes on top of that. So we're going to have a nice deep channels. This is 3/4 inch rebar that goes here, and then we're going to have the 1/2 inch in a 2x2 mesh that goes on top of this.
A 1/2 inch. I said, and here you can see it right here, and a 2x2 mesh, fiber mesh. There is no 2x2 fiber mesh, as you can see. I mean, a 2x2 mesh rather. You see it? Not present. So therein lies the devil in the details and killing the engineer's request. He said it was engineered. All right, unless the engineer changes his request. But changing the request doesn't help with national building codes requiring that you don't do things like this. This is just exposed concrete. I mean, it's just randomly bent too with the guy's foot, as you see. It's down here. This one goes under. That one goes over. This one comes back down. It's just some weird profiling going on there. This one stops here at the edge. It doesn't turn and come down and continue, developed into the wall. It just stops at the edge. All right, and it's back off the edge by I don't know how many inches that is. Wish you guys the best. I just wanted to shoot you some nice little defective stuff here. Here's this one. You can see the shadow underneath of it, so this one's not sitting either. It's floating, so it's going to make it higher in the concrete. Possibly only 1 inch of cover. All right, take care. Bye. And for safety reasons, all these should have protection on them. and they're greater than 10 feet. You don't want them falling off the structure. Should have some type of fall protection. Okay, take care.